Hello everyone, my name is Hanae Rateau. I'm presenting today the work entitled Leveraging Smartwatch and Earbuds Gesture Capture to Support Wearable Interaction. This work has been done at the University of Waterloo and in collaboration with Huawei. So it starts from the observation that we have more and more connected devices, and whether it's smartwatches or headphones or workout machines, we also have more and more signals from these devices to exploit at the same time. And with more devices, that means also that we might need to interact with them while being used at the same time. And so to broaden the interaction possibilities, gestures appear to be an interesting candidate thanks to its expressivity. And those gestures could be done around the device of interest. So for example, here on the drawing, we are using a pinch, and by either going up or down, we could lower the volume of the song playing in the earbuds. So obviously, we are not the first ones to think about this. And for example, you can find technological solutions for non-touchscreen interactions, and as well as ear-based inputs. But what we were more interested in first was to know what kind of gestures we would need to recognize first. And so we turned towards the work including elicitation studies and social acceptability studies. So the closest to our work is maybe Kerber et al., who elicited gestures using the same arm as the arm wearing the watch, and found that a good portion of those gestures were of symbolic nature. And in this study, participants were not asked about the social acceptability of the creative gestures. Well, on the other hand, Chen et al. Said they study in public environments like coffee shops, and they asked participants in front of a screen to create gestures. And here, participants were instructed to create gestures on the ear or near it. And when we look at the social acceptability studies, we can find Li et al., who wanted to explore subtle hand-to-face interaction. And so they prime participants to create subtle and obfuscated gestures. In the work of Macmillan and al., they found that the acceptability of the smartwatch is highly dependent on the context, and especially when you switch from private context to public environments, which is also shown in the work of Rico and Brewster. And they also showed, interestingly, that the location and audience has a great impact on the social acceptability of the gestures. In the work of Alstrom et al., they studied the gestures around mobile devices, and most interestingly, they found that bystanders perceived the gestures more socially acceptable than performers, even if it's the same gesture. So what we wanted for our first study was to elicit gestures for interaction with a smartwatch and earbuds, and not to restrict the space of the gestures except for the natural limits of the arm. But we also wanted to have some feedback on the social acceptability in different social contexts, not just public contexts. So this study was done during the COVID lockdowns, and we had to deliver the smartwatch and the earbuds to participants, and all the interviews were made via video chat. So during the study, we presented 19 tasks in a random order, and for each task, we asked participants to create a gesture. Then the gesture was rated by the participants on a 5-point scale for characteristics such as memorability, so how easy it is to remember the gesture, its suitability, and its simplicity. Then we asked participants how they feel this gesture would be appropriate if they were to perform it in 8 different social contexts. So at home, at work, and in public contexts. About the tasks, so here you can see all the tasks that we presented to participants, which shows smartwatch-centric interactions as well as earbud-centric interactions. So you can find standard navigation tasks, all the commands related to calls and listening to songs and volume, as well with the microphone. Then menu navigation tasks, and then voice assistant and how do you connect devices between them. And so from the interviews that we recorded, we classified all the gestures made by the participants according to this taxonomy. So we have 8 dimensions in this taxonomy: the nature of the gesture, it's whether it requires a context to be interpreted correctly, its temporality, is it in a closed loop or just made once, then its duration, its size. So for example, does it involve only fingers, or the fingers and the wrist, or fingers, wrist, and arms? And then the complexity of the gesture, is it a sequence or not? And finally, the location on the gesture, whether it's done on the head, close to the ear, or far from it. So once we classify those gestures, we calculated the agreement rate according to the formula from Rateau and Woodbrook works. And here you can see the group that we made and we used to calculate the agreement rate. And when we look at all the high agreement gestures, all the gestures were generally small gestures. And we find in those gestures for the task like next and previous, act on selection, zoom in and out, pan horizontally and vertically, read a notification, answer a call, and play and pause. And so this is the set with a high agreement rate. And we can find all the navigation gestures in it with small gestures. And interestingly, as you can see, 23% of the gestures are tab-based and 12% were swipe-based. So which kind of suggests that participants transferred their knowledge from using touch-based devices that they know, like such as smartwatches or modern headphones. And then we can see here the taxonomy breakdown. So for each dimensions, we classified the gestures, and we can what we can see is that most of the gestures were abstract, discrete, simple, and in context gestures. And interestingly, you can see that around 40% of the gestures were made on the head, and the remaining was into mid-air, which is a bit different from what the previous work showed. So then we asked participants about the social acceptability in 8 different social contexts, and then for each gesture we ran cross-coriolis edge test for each social context, and we looked at how gestures characteristics on each dimension influenced social acceptability ratings. And so here you see the accumulated bar plots of the social acceptability ratings for each context and each location. For example, here you can see that gestures made on the head were all rated as appropriate by participants, like they were rated above 4. And as you can see in the remaining, on head gestures were overall rated higher, so more socially acceptable than the other gestures made close or far from the head. And this comes from like several participants stated that on-head movement could be interpreted as scratching gestures or natural common poses. So it wouldn't feel awkward if someone would see them perform those gestures. And so here, this is the same thing, but for the duration dimension. And interestingly, we can find a significant effect on the duration when participants were with acquaintances. And we can see that short gestures overall were rated higher than medium and long gestures. For the size, overall, small gestures were better rated than the medium and large gestures in all contexts except at home contexts. So we can think that people are more familiar at home, so they are more comfortable using gestures around the ear. And participants were also concerned about hitting other people in public settings if gestures were too large, and they also did not want to draw attention of others. So from this study, we have several guidelines. So the first one is that people prefer small and short gestures. Then also for similar, we would use similar gestures for similar tasks. Also take advantage of the prior knowledge of participants with touch-based devices. And if you have to use large gestures, it's better to make it obvious what it's for and that we are actually interacting with something. And so from these guidelines, we created three new gesture sets. And here you can find a short video that showcases some of them.
Your reservation for 2 at Luigi's has been confirmed. Add to your calendar.
So those are some of the gestures that we created using the guidelines that I've just presented. And then we wanted to run a last study that confronts the social acceptability ratings from the previous participants with the point of view of the bystanders. So how do bystanders react to the gestures that we created? And we also wanted to see how the guidelines-based gestures would influence the social acceptability. So that's why we used all the gestures from all the 3 gesture sets that we created. And so we had 44 gestures, so 44 videos recorded with one of the researchers performing all 44 gestures. And then for each video, each gesture, we presented to participants. We asked them to rate the social acceptability in 9 different social contexts and its appropriateness. So the main takeaway from this study is that overall on-head gestures are still rated more appropriate than in-air and large gestures, which resonates with the previous results. And an interesting point is that we still observe positive ratings even for large gestures. So they are not as inappropriate as the previous participant might think. And finally, we also observe lower scores for contexts in which there are social interactions, like during conversations or meetings. So in this work, we have one illustration study that results in guidelines and the creation of 3 gesture sets for smartwatch and earbuds interaction. And we also have the input from 2 social acceptability measures from both the performers and bystanders' point of view. So as future work, we'd like to investigate the feasibility of interaction between smartwatch and earbuds at the same time in combination. And we'd also like to see how would it work with other devices, not just earbuds and smartwatches, and even like the new mixed reality devices, since they offer different signals as well with different affordances. So before ending this talk, I'd like to dedicate this work to Ed Lank, who passed away earlier this year. This is the last work we worked on together, and he was very excited about the possibilities that it opens. So that's the end of this presentation. Thank you for listening, and I'll see you at the Q&A.